Hi, Stuart here. Today, a little bit of a departure for this channel, and that is I am attempting to make an example REST API on the old and familiar person, object, and collection. You can go and contribute to the project. You can get all the code, which all runs off your machine. You can read the README for how to do all the setup that you'll need, which isn't much. The ingredients are the tools, Node and NPM, which is the runtime. Usually when you install Node, you get both installed. The first thing I do after it installs is run the updater to see if there's an update. There's the Jest tool, which I typically install globally on my machine, and JSDoc, same thing. And then I love VS Code for any kind of JavaScript project. I also use it for Python and PowerShell. Key libraries, very few of them actually. The biggest one is Express, which is essentially the middleware that wires up your API. So you set up your entire stack of interceptors, things that intercept the response and reply, which is a U-shaped curve. And Express is where you use it. It also has a little add-on blister that will deal with some of the async methods. That's very handy. Morgan and a rotating file system is how we're doing logging. If you use Morgan and substitute something besides the rotating file system, you can hook your code up to run against Azure App Insights or Google or the Elastic Stack or whatever. So Morgan is a great base. And then you can pick essentially the sync that you want Morgan to write to. CORS obviously is important. We want to always make sure we're implementing cross-origin resource sharing rules. We want an Open API 3 specification that we doctor up. We'll show you that. And so I'm using Swagger AutoGen to actually scan my route classes and generate the Swagger. And then I'm using Swagger UI Express to generate the Swagger page, which allows you to interact with the API really nicely. Some teams may want to disable this in production, but typically what you do instead is you would simply set up whatever's in front of your API to not allow the Swagger page to be accessed remotely. I use Faker.js to generate realistic data. The original Faker was written in Java, but has since been ported and improved to JavaScript, C#, Python, etc. It's a great tool for generating realistic looking data. So all the data that you're going to see in the demo, that where a person has a reasonable first name and last name, and they have a reasonable company name and so on, is all generated by Faker. So what about security? So in this demo, I've split security into 3 concerns. Concern number 1 is identity and access management, which we're just going to assume that there's a third-party thing sitting in front of our API, and that our API will never get called if that identity and access management fails. For things like controlling the headers and so on that are within the grasp of the developer, that's implemented as wire-up in our code. That could also be deferred in some cases to something like Apogee. In this case, since this is an out-of-the-box, ready-to-run demo, I'm demonstrating how to do it in code. But if you decide to implement it in infrastructure, then you should take out those parts from the code, because there's a fundamental rule you probably heard me say a bunch of times. A person with 1 watch knows what time it is, with 2 is never sure. In other words, have one source of truth to configure a particular thing, and only one. So if we decide to do it in, say, Apogee, we should only do it there and not do it in our code. And then the second domain is the domain of secrets and configuration. I have a little narrative about that you can read. You can see my other videos where I go into that in some depth. In this case, we're just simply setting environment variables as if they were set by a continuous deployment pipeline. And you'll notice the best practices there are that everything has a reasonable and known default so that it won't just launch into space. The alternative, if you don't do that, is to make sure that your app will throw and crash on startup if it's missing its must-have configuration. So those are your 2 choices. Provide sane defaults or ensure that you got a definitive configuration. And those 2 things aren't mutually exclusive. You could say, for this domain of configuration, having sane defaults is perfectly great, but there's these 3 or 4 things, And if they're not set by the pipeline or through some external mechanism, it's absolutely no good. I want the thing to crash. It will never run properly ever with that configuration missing. It is a critical fail. The third thing is best practices around your runtime environment. In other words, your host. In this case, I have a little sample Docker container that I run, but I had trouble getting it configured to run as a low non-root identity container. So that bits aren't checked in, although they may be checked in by the time you watch that. Or someone may have done a PR that says, for this Docker thing, you should be doing this. Here's my PR. And, I try it and we like it and they get credit and we fold it into the repo. When you're looking code, make sure you have done get latest, or if you're forking it or cloning it, just make sure you do a git pull. Okay, first thing we're going to do is a git pull just to make sure. And we're already up to date. Then we're going to do an npm I, and we're going to make sure that everything is up to date. Then the next thing we're going to do is regenerate the Swagger. So this is the Swagger regenerator, and that's done. We'll get into that code in just a minute. And then we'll go ahead and run our Jest unit tests, and those are running away, and those pass, and that's great. And then the last thing we're going to do is we're going to regenerate the documentation for the API. So let's go ahead and do that. We're going to do that by running scripts invoke JSDoc. And you can look inside and see what that does. And now basically everything we needed to do is done. And now we could do a node index.js to start. So let's do that. And we will take a look at the result at the site, and then we'll take it apart and see what we get. So what you get is your favorite Swagger page with the version and contact information, the servers that it's agglomerating on. I'm running on a very high port, 383 on purpose. It doesn't collide with anything as far as I know. So that's my favorite in demos, just runs on that one. I just picked it at random. And we can do things like we can say, well, let's go get all of the people. And you'll notice that we get a lot of really good control headers here, InfoSec headers. Read more about those on OWASP.com. And we get an empty list because we haven't added anybody yet. So it turns out that there is a handy-dandy method that will generate well-formed random people. So I'm going to generate 3 of them. And you can see that thanks to our friend Faker.js, we have some perfectly reasonable looking people. The email addresses, of course, some of them are invalid. Why? Because they have a space in them. But this is test data. We're not emailing those people. So, and then we can do all the usual things where we can take this little snip of JSON and we can say, I'm going to edit this person. So I'll go ahead and do a post and we'll paste that in there. And let's just say, for the sake of the argument, that that's actually supposed to be STD OUT. And so we'll hit execute here and we get a 200. That means it was edited. So if we go and we grab the ID and we go call get by ID and paste the ID in, we can see that that has been edited. And likewise, we can add, delete, do whatever. The other things I want to call out is I always add 3 methods to my APIs that are reasonably standard practice across the industry. The one that for sure is a standard you should always implement is getHealth. And getHealth returns a 200 healthy if it's correct, 500 if it doesn't. In this case, I have no other dependencies, so this one just always returns 200 healthy. But the point is, you should have a health check end. Likewise, you should have an about endpoint, and the about endpoint will yield the version and some metadata about, the license and the, where it is in Git and all that good stuff. You can put whatever you want in here, but it's just good courtesy to have that be available. And likewise, the other thing you probably want to contemplate doing is to allow people, particularly developers, to download your OpenAPI specification. And here we get back the OpenAPI spec, and I can go to Swagger.org or use whatever my favorite tooling is. I can feed it this piece of JSON, and I can have it generate a client for this API in almost any programming language I want, and it'll be a pretty good, fully functional client in most cases. Sometimes you have to play with them a little bit, but if you, for example, are told that the API has changed, you can go and download this, and then you can run a diff tool against the two versions of the JSON and see if there's something that's changed that you need to know about, particularly if there are breaking changes. That's bad manners. I'll point out we are using a semantic version here, 1.6.4. So 1.6.5 promises us what? It promises that there are only bug fixes. 1.7.0 would promise we added things, but we didn't break anything that existed. And 2.0.0 says this is a breaking change API. There are probably many broken things, and those things could be syntactic or semantic. And again, I have a YouTube video on that. Please go and watch it. So these are the 3 best practice things to add on. Again, in our API gateway layer, we can say you can't get to any of these from the outside world. You could also say you can only get to the endpoint if you have a token or other security identifier. All that good stuff. We didn't do it in here. We did it. We're assuming that there's an external one. And that's a best practice, is let infrastructure do it if you can. So now that we know about, the output, what this thing makes, which is a functional person API that runs against a internal memory list. In the real world, your repository would be to point at SQLite or your favorite NoSQL database like Mongo or whatever. But again, there's no external dependencies here once you npm'd on the tools. So that's a nice, manageable demo. Okay, now that we've done that, let's drill into some organizational things. So we're using VS Code. So there's a .VS Code folder in which there is a launch JSON, which I did check in, which is unusual, but there's no secrets or anything in there. This shows you how the various bits are run. So there are scripts in the script folder, and they are PowerShell. And one of the scripts regenerates the documentation and does some cleanup and markup. You can see how that works. And one of them is what packages this as a Docker. You see a Docker ignore there, and it will try to package up a minimum Docker. Let's just spend a minute on that. The Dockerfile itself is absolutely minimal. Again, we're looking for a pull request contribution to make this run as a regular user. There is a Node user on some versions of Node, and I am using Node Alpine, so the whole container is going to be pretty small. I am running Docker on my desktop for the purpose of this demonstration, so I'll just be running it against on my system. But there is Docker apparatus that we're going to build out over time. Likewise, there are other best practice elements. We have a robots.txt that basically says nobody does nothing. We have a README with the configuration and installation instructions in it. That's a good best practice. We have a prettierrc that will be used by VS Code to auto-format all the code to the shop standard. And so, this could be something that gets copied into every repo. There's likewise an ESLint config that does the same thing and says what to ignore and what not to ignore. Very few rules in here, but these are best practices things when you're setting up a project from scratch, right? You want to set up a gitignore and a Docker ignore and an ESLint config.js, and you want to set up the instructions, you want to have all your packages installed and a robots.txt and a README and so on, right? These are just all the things that you should add to a project to have a well-rounded out project. You'll notice that some of the folders are coded gray instead of white, and those are the ones that my gitignore is ignoring because those are generated. So the coverage folder is what you get when you run Jest -- coverage. And it's got a coverage report in there. So while I'm building out the software and doing my tests, I can see if I've got good coverage, testing coverage on my libraries. The docs folder is where the JSDocs are going to end up going. The logs are where the application writes logs. And we'll talk about that when we actually look at the thing that does the configuration. But those are being written as W3C logs for compatibility. But again, those could be going to anywhere. You could have a sidecar in Docker that takes them off to Elastic, which is one of my favorite things. But you could use App Insights or whatever you want. But the point is that, for the purposes of this, we don't really want to check the logs in. We don't want to check node modules in, right? If we're coming to a clean machine, we always want to do an npm I. and or npm install, and make sure that we have clean copies of all of the modules in. It will also warn you about anything that's kind of sketchy security-wise. And we have our MIT license in the root folder, just to make it clear that, you can copy this, but, there's no warranty, none. If this, eats the universe, it's not my fault. Okay, so the place to start exploring this is to just go through the folder names, and then we'll open up index.js and we'll dive into it. And then on your own, you can just go git clone this, or git fetch this if you want, and you can explore this in more detail. You can also see how we use Jest to write tests. I'll show you one of the tests for the people model in a minute. But I have a data folder where my repository library lives. I have a config folder where the code that processes environment variables and such same defaults, as we talked about, lives. We'll dive into each one of these places that I'm showing you. We have a middleware folder and a routers folder, and the scripts folder with the PowerShell. So let's open up index.js and do a walkthrough. So this is the entry point for my app. And you'll notice I'm using JSDoc style comments. That's done throughout. You can see that I've gone out of my way to be as careful as possible to give things the metadata that it needs. If anybody looking at this looks at the output documentation and goes, you know what, you can do better than that, then please file an issue or put in a comment or do a PR if you're feeling, helpful. So the next section is we're going to go get all the environment variables that we set up from our config directory. And those are all the environment variables that are exported from that module after they've been processed from the shell. So in many cases, these are cleaned up from what actually is in the environment, or in some cases they're transformed. Like port was a string as an environment variable, but it's an integer, a number in JavaScript, and so on. InfoSec NOH which stands for no headers, like remove these headers, is actually a list, because we want to be able to loop through that list and see it. Then we have our requires sections above this. Some people would put this requires block above that one. I don't think it matters particularly, as long as you go get things before you start using them. And you can see we're using Swagger UI and Morgan and the file system and path and the utility library that I wrote that's got all my sort of general purpose JavaScript libraries. I stripped out all of the functions I wasn't using in this project using a little manual tree shaking. I could have done it with tree shaking as well. I chose not to in this project. And then here is a super useful global. I am not a fan of globals. I think mostly they're awful. But there are times when there are globals that are just super helpful. And this global of where is the file system root of my project? In other words, where does index.js live as a fully qualified path? That's why we're resolving it. One of the few environment variables you're going to find in every single one of my projects, even if I don't use it, because I'd rather have it and not need it than need it and not have it. I do use it in this. It's used for Morgan and other things. So, that's a good thing. We set up Express middleware. You can go, there are lots of good tutorials on, including the Express.js site itself. And we say, our app object is Express. So what's actually happening there, right, is, other than going and getting the library, obviously, is that there is a self-executing function called Express inside the Express library. And it makes a new object called app. And that app exposes properties and methods that we can then use to build up the middleware stack and then finally use it to listen on a port for incoming requests and then make sure that those requests are processed properly. And again, we'll dig into that as we go through this. But fundamentally, right, the app object represents your application and what it can do. And the very last thing in the file is generally app.listen on a port with some other parameters. We'll see that too. But just understand that everything between here and there is all about setting up the middleware. What is middleware? Something that listens to requests and is capable of outputting a response. And that is true of every single component of our web API. We're making a big U-shaped stack of things, and as each level fires, it either chooses to do something or it doesn't, and then it calls next, which is the next handler in the chain. So the order you put these in is the order that they are put into that stack of request and response handlers. So order matters. Not critically in some cases, but in other cases, it's super critical. And so as we go through here, I'll remark on the places where, it doesn't matter what order these things are in, but there are other places where it absolutely matters. For example, your error handler has to be the very last thing before listen. So the first thing we're going to do is we're going to set up our logging. And in this case, I could make this chunk of code from 48 to 59 so that it went to App Insights, or it went to Elasticsearch, or it went to Google, or whatever. So the first thing you do is you set up one or more sinks or places you want your logging output to go to. And in this case, for the purposes of demonstration, not that I'd ever do this in production, if this service had to scale, we'd make a bunch of changes. But for the purposes of demonstration, it's great because right out of the box, your logging becomes one line of code. App.use, Morgan, we say we want the combined format. There's a bunch of different formats. You can go look at it, but the combined format basically has pretty much every single field you can put into a log file using Morgan. So everything the Morgan intercepts and makes pretty for you. And then we're just telling it, hey, I want you to write it to this rotating file logger, the access log stream object. But Morgan is great. It's simple. It's battle tested. It's well behaved, etc. The next interceptor I want to set up so that all of the interceptors down from the use Morgan line on 64 will be able to write logs to Morgan most of the time without a single line of code on your part. So we want to configure cores, and we want to make sure that if we are in something like Dev or QA, these both could be star origin methods. But in the upper environments, you want to have pretty strict policies. That's why these things are environment variables that we grab from our environment variable post-processing. And why do we do that instead of just grabbing them out of the environment directly? Because we want to do some interception and have sane defaults. And we also want to allow ourselves the opportunity to throw a critical error if some piece of must-have configuration that can't have a sane default is missing. So the pattern is, don't grab environment variables from more than one place. Like, make yourself a config handler and then require it wherever you need those values. But there should be one source of truth for interpreting those, and it should be your JavaScript. And we'll show you what that looks like. It's not super fancy, but it's useful. So again, focus on one source of truth. So we set up cores, and then we wrote some custom InfoSec middleware. So InfoSec is the people in most organizations that enforce all the rules. And you'll remember from the demo that we had a whole bunch of headers that we had added to make sure that we didn't get cross-site scripting attacks, or we had invalid content types. We have a way of ripping out all of the headers that are produced by, say, Express or Node by default. That would expose things about our app we don't want exposed. In this case, there's only a single header. But in other environments and with using other tools, it's important. And again, very simple, right? We set up our middleware somewhere else. We include it in. We set up its configuration by pulling in the configuration from our single source of truth, our configuration manager, and then we wire it up, right? So we want these things very high in the stack. And then we want to wire up Swagger. So again, we go get the Swagger file that's generated from the Swagger script, and we'll explain that in a minute. And then we want to set options. You're seeing a little pattern here, right? Require options setup. Require options setup. That's is a good pattern, because among other things, we have this nice big comment block. This is going to be easy for people to find, easy to maintain. So things that are not, universally needed throughout the thing, people would say, well, I think all of the requires should be at the top. And I'm like, well, that's great, but you know that JavaScript is going to hoist all the requires to the top at runtime anyway. So why not put them in these blocks where they're useful? We're wiring up Express.json, which is the handler that turns JSON into objects and objects into JSON, so that I don't have to do that myself. Now we have our routes. So we have two modules. One that handles all the person API things and one that handles all the info things. So it handles health and about. OpenAPI 3, we put them into different routers, and we'll show you how to construct a router in a minute. But the idea is super easy because there isn't any configuration to be had here. It's require no configuration needed. I didn't bother to put a comment in, and then use it. And then once we've set up all the routes, we can say, okay, well, if somebody hits the default route, redirect it to the Swagger page. Again, if you have an appliance and you have a rule that says, well, from the outside world, you can't hit Swagger or health or whatever, that's absolutely wonderful, because what they'll get is a 404 error or a 500 error, depending on how you configure, for example, Apogee. Now, there are some security professionals that say you should never return a 404 because it tells a bad guy about something. You should always return a 500. But I find that tremendously unpleasant to the people who are using your API. So what I do instead is I return the expected HTTP status code, and then in Apogee or Azure app, I will go in and say, if you see a 404 coming back, I want you to return 500 server error and nothing else. No body, nothing. It'll even strip out the extra headers if there are any. And then we're not, we can have an API that's friendly to our friends who are going to use this on other teams, and we can have our security too. So it's really important that, we disambiguate our API consumers. External API consumers get little or nothing other than the functionality, and internal API consumers get friendliness, right? That's desirable behavior. But again, I am letting the infrastructure handle it, because then the InfoSec team can come and ask the infrastructure folks to dump the configuration and rules. So we have the redirection, and then, as I said before, your error handler should absolutely be the very last thing before listen, because that means it'll be the last handler invoked in the call chain. So if something throws and you wire the error handler at the top, it'll never catch it. But if you put it right before the listen and nothing else in between, then it'll be the last handler that was added, and so it'll be the last handler executed. And if there's an error, your middleware handler will be invoked and do the right thing. And then we start listening. And it's traditional to do a console.log, but you could do a log here. You could do whatever you want. But just, again, the upcoming best practice on logging from apps that run in containers is probably to write to standard out and standard error and have your fabric capture it and then sort it off to logs. And then that way all developers have to do is write standard out and standard error, and the right things will happen. If they have something like Morgan, whose default is that, they will be able to get beautiful, consistent logging that can then be handled by your infrastructure and go off to Elastic or go off to App Insights or go many places, right? Totally unbeknownst to the developer if you don't need them to know. So this is it. I am wiring up my stack, and and it's very few lines of code. Now, agree, this one isn't very complicated, but the reality is the only thing that would change if I were writing a different service probably would be to have more routers, because I might have, for example, an account service, and it might have, different routes for different use cases. But I'm always going to have info routes, right? And they're usually the last routes I add, just in case there's a name conflict. In order to build the Swagger that we saw, we needed to generate the JSON. But in order to generate the JSON that is in the OpenAPI 3 format, we need to not only be able to generate it, but to intercept it. So let's look at that now. So this is a little script that is not going to run as part of our app when it runs, but it's an example of how to dog food. What does dog fooding mean? The same tools you use for development should be the same tools you use for as many other things as you possibly can. And again, I have a nice big JS chunk at the top. I've got my requires, and then I go get my configuration. In this case, it shows you from highlighting, I really only need this one, but they're available if I need them. And then I want to go through and say, okay, well, if the port is no good, I don't want the port, right? I don't want to generate Swagger with a bad port number. So I do a console log because it's a utility script, and then I can build out my objects. So if you're using Swagger in a language that has strong types and is introspective, in other words, it supports reflection, like C# or Java, their generators can generate from the code that's running, it can generate these objects. But JavaScript and Python really can't do that kind of deep introspection. And even if they did, they may not give you things in the way you want them to be in. So in this case, I've got a real simple little person object, and I handcrafted this little comps block because I went and looked at the openapi.org instructions, and I said, okay, well, the comps block is a block all by itself. So that's what the yellow opening brace is. And then it has a components collection. Inside the components collection, it has schemas, and those schemas are not a list. They're not a list. They're a dictionary. Why do we know it's a dictionary? Because it is yellow braces with commas, right? It's not a square bracket, it's a brace. So it's expecting a dictionary, and that dictionary is actually a dictionary of dictionaries. So person and people are in the top level dictionary, and then each contains a sub-dictionary that has the definition. We define person, and I went over and looked at my person object and got all of the field names, and I, gave them little comments. And then I said, well, in the aggregate, I have a people object, and the people object is an array of persons. And that's how you do the mapping to another component. And by the way, that component can be anything that's defined by the OpenAPI 3 spec. So in addition to being able to reflect on your own types that you made, like the person and people class, I am able to find types out in the outside world. And as long as I either put a reference to them in there with a fully qualified URL, or they're well-known types, the generator will go get them and fill in the right metadata. And then the very cool thing about Swagger AutoGen is this amazing line of code. You say what the endpoint files are. And I'm super neurotic and tidy, so, I have all of my different major endpoints with the entry points in those endpoints in their own files, and you just tell it what the files are. And then you run Swagger AutoGen, this one line of code, and I could just stop before then with a semicolon, and it would generate perfectly good code. But I want to do some gentle editing, right? So it's a promise, and that's awesome sauce, because right inside the promise, I can say then data, right? And that's everything that there is to say about that. And I can say OpenAPI 3 equals the output file, and the output file is named Swagger.js, right? And here's a little dumb trick. If you have a file in a well-known format that can be automatically converted or assumed by NodeJS as a JavaScript object, as in fact JSON can, or in some cases XML can as well, you can just use require. And OpenAPI 3 is now the object tree as a JavaScript object, right? Object.prototype of the contents of that file, where the properties are, dotted, right? So if I go look at Swagger.json, I'm just including this whole file in. Each one of these things becomes a top-level property: OpenAPI, info, servers, paths, etc. So in code, I can just refer to the elements I want. And in this case, I'm reading my package.json file to steal things like the author, me, at least to start with, and I can steal the version of the package and package.json. I can steal any elements I need, and then I can go through and hard code in the things that are hard coded, like the path, the license, the path to the GitHub, which is probably never going to change. Notice one nicety here. That's just a general JavaScript thing. If you want to add an object, have a property, in this case contact field, right? You need to initialize it to an empty dictionary first, and then you can say ... all you want. How cool is that? And in this case, I am using my configuration variable because I want to set service of 0.URL to localhost so I can test. And then all I need to do is take my OpenAPI object and stringify it. In this case, I decided when I called stringify that I was going to indent it by 2, so it's going to be basically pretty JSON instead of icky JSON. And then I was just going to write it out to that file. And what you get is you get initially a JSON without these blocks in it, without these objects, these components, right? And then after it's done writing, it's been enriched with all the stuff I was missing. So that's pretty cool. And now this is an open API spec. Again, you can give it to anybody. They can generate a client. They could even generate their own server as a test server if they wanted from here. Now, we're not describing a lot of the behavior in here, but if you have, a document that describes that or whatever, that's pretty cool. And they can't really generate code from behavior descriptions anyway. All right, that's spiffy. So let's go and take a look at our config object, which is the environment variables config object. And I, again, am sort of death on the everything in one and only one place kind of thing. I don't like duplications of things that are logic. And I don't want to put too much pressure on whoever's configuring the pipeline. I'm just going to assume that all the environment variables are strings that need to be coerced for a type and then checked. And, if it's not legit, then it doesn't fit. And I YARP about it, or I reconfigure it to have a default behavior. So we've got some constants at the top. We've got our port logic. Notice that we're checking existentially to see whether or not that's even a port, or if the port's an illegal value, and we're setting it to the default port, right? In this case, we're using coalescence for all of these different things that you can configure about the behavior of logging, about the cores, about the InfoSec middleware. Notice that I have a naming convention for environment variables. They're all uppercase. They use an underbar, not a dash. Why? Because that works on every operating system that I know about that I'd ever want my code to run on. That's why. And then at the very end of doing things like taking this string of the no header string, which is a comma separated string, I'm going to go through and coerce that to the variable I'm actually going to export, and then I'm going to export the explicit variables. And so the ones on the left-hand side are what you'll actually see when you require this module. And that's just very tidy. And this is typical of the things that you want to do to make sure that your code is super usable, right? All of the configuration for this project is 100% in environment variables. If they're missing, they get sane default values. But if you needed to, this is the module in which I would crash the thing, right? I would crash Node. If something is missing, like the authentication hash key, and you absolutely have to have it, or nothing works, nothing is secure correctly, then you need to crash it if it's not in here. But put it in here. This is where it goes. In here, we have a fake repository called person repository. And you'll see this is just very low brow. But for knocking out a quick demo, you'll notice that I was as meticulous as I could think to be in JSDocing all of this. But, this is my fake repository. And all of the I/O for all the people happens through the repository and doesn't happen through anything else. So I could rewrite the guts of this to be SQLite, and the consumers of this, the people writing the routes, would not notice. Again, we want to encapsulate, right? It's all part of being solid. And of course, being a good camper, I wrote some nice tests. And again, one of the things that's really great about Jest is that there are so many contributors to Jest that have done so many good things, and as dumb as my tests are, they're really basic. There are some really spectacularly wonderful additions to Jest that allows you to test darn near any scenario. And I like Jest because if I ever have a problem, I can Google my way to happiness, even if I'm using Bing. Here's my utility library, and you can see I'm just using a self-executing function and returning a bunch of utility functions. And why is it self-executing? Because that's the easiest way to export a bunch of things. I could have made this a class where everything was a static, but it transpires that I wanted to show a couple different ways of doing things. And so this is the old school way of doing this, and it just works. And so I have, lots of variations of utility that do simple string and date manipulation. And this method makes a date stamp. It's all padded out, all pretty, that I use in file names and stuff like that. Let's go look at some middleware. Let's look at the error handler. Fits on one screen. Notice I'm starting every single one of these with use strict so that my ESLint, when it runs in here, it's running continuously against this, right, is going to remind me when I type something dumb. So here is an agglomeration of different middleware error handlers that I have sort of collected across different people, and different people had different ingredients, and many of those ingredients were missing parts. So this is the Stewart version. If you hate it, do a pull request or put an issue in or whatever. One of the things that is super important is if the headers are already set in the response, that we invoke next and we don't do anything else because it's too late. And the only time that would happen is if this isn't the last handler or the previous thing did a response.end or response.flush. So, but this is just a safety check to keep your API from having an error and then cratering in a cloud of fire and smoke. These little 3 lines of code are life-saving. We're doing coalescence, and then, we're just putting out a standard message. And again, over an Apogee, I could suppress that message and replace everything with 500 server error. But I don't do it here. I try to give a friendly error message back to my internal consumers because that's the primary people I care about. Here's my InfoSec middleware. Again, super strict. I define a configuration object and document it. And then the module exports is an anonymous function, otherwise known as a lambda. And I go through and say, okay, well, if property CSP is valid on my options object, in other words, the property exists and it's not empty, then I'm going to set the header to its contents and so on and so forth. And I do that a bunch of times. And then down at the bottom, because banned headers is going to spin through all of them, and I'm going to say, well, if it's a valid header, I'm going to go ahead and remove the header value. And again, when I'm checking, I notice that the level of paranoia of checking here, right? I go, is this thing an array? If it's not, don't do nothing. And then for each item in the array, I'm like, is this a legit item? Notice that empty string will be false. And so it won't execute, because if you call res.removeHeader on an empty string, it blows up, gracelessly stopping our code. Build guardrails into the things you build is what I'm trying to say. So here is an ISMA class using the newish class keyword, although by now, if you're not using classes and you don't have to be super backward compatible, you should, because classes guarantee closure and other certain behaviors that normally you'd have to get with a self-executing function. And, classes are a lot easier to read, particularly if you put JSDoc comments in them. So I define a constructor, which also defines all the fields on my class. And then I've got a bunch of different properties, including the toString, from JSON, from object, and always put a validator on your classes. The convention in places where I work is always to have is valid in whatever casing is the shop standard. But you should, for all of your classes that are DTOs or they're any kind of model, right, you should have a validator. You should probably have a toString method. You should probably have an equality method. You should have transmutation methods like from object and from whatever. In this case, the language provides a really great way of doing a to JSON. So, but in languages where JSONification is much harder, I tend to provide a to JSON overload. And again, I'm going to set up my tests to test my class and make sure that it does all things it needs to do. And you can do that in surprisingly few lines of code with Jest. Jest is not verbose. Here's a test, here's a bunch of expectations, and then they use, to be and the answer. And that's great. Okay, let's talk about the routers. So here's the info router. How do you make your own middleware? Well, we've seen how to do that with the error handler and the InfoSec middleware, right? Where they're both, one is doctoring headers and the other is handling adverse conditions. To do your own router in the Express framework is pretty easy, but there's a couple of subtleties. So we've got our uses and things like that, we're once more asserting that we want to use express.json. I left that line out and it acted kind of hinky, so I put it back, but I don't think this should be in your code twice. So that's a question mark. If you want your code to just work, router.get, router.post, router.whatever works fine. If you want JSDoc to have better documentation, it helps to assign them to a variable, because then it will reflect on that object, so to speak, and pull out its metadata and produce better documentation. It's a night and day difference. So there's a little tip that was really hard to figure out. And so for each of the methods, we get the about, we get the health check, we get open API, we have a handler, and in the handler, we do whatever the handler needs to do. And in this case, again, we're parsing packages.json and getting a bunch of data elements and making sure they're populated. And then, doing my favorite thing, which is res.status.json. That's all over the code. And if you're writing an API, that's a pretty good one. If you need your API to do either XML or JSON, depending on the accept content header, you have to add in another library and do a little more work. But then I think there's a thing called result that's added to this, and result will format your JavaScript object, which is what result is, right, to be in the right format, XML or JSON or whatever. But in all the shops I work in, XML has gone the way of the dodo, and so we just don't use it anywhere. So we just use hard-coded .json everywhere. Person router. Person router obviously is going to use the person repository object, and in most cases, look at that, one line gets all of the rows from the repository. Now, you wouldn't want to do this in real life if the repository had lots and lots of data in it, right? You'd want to have paging arguments, you'd want to have filtering arguments, right? But this is a demo. The last time we did one of these, I got this torrent of hate about, that will return every row in the database. And I'm like, yeah, it's a demo. I have demos actually that do much more erudite things, but those are about videos about doing erudite things. So go watch those, and then if you need it, put it into the samples, or your own as you're building things. So this has all the usual things. Notice that in no case do I trust the input from the end user, right? I coerce them. I look for them. If I were really serious about this, and there were things that were parameters that, for example, had to be strings, that in this case I'm getting the ID by coercing it to a number. In this, I'm coercing it to a number. The thing that is important about this is that, in the real world, you don't want to trust user input at all. So one of the things that is built into person repository is it's actually checking the parameters that are passed to it. And you could double check them in here in the routes if you wanted. But the deal is, if you are the author of a repository, you need to make sure that all the business rules, including not being able to do SQL injection attacks or whatever, that you cover off on. That is your job, so that the people who are just trying to wire up don't have to. And then there's some PowerShell scripts you can dig into. But that's a quick introduction to the code. I'm actively soliciting your pull requests, your issues, your suggestions. The goal here is to make a simple Node.js service with very few external dependencies that demonstrates as many of the best practices as possible. Before you ask, yes, I will be adding examples of GitHub actions to do a CD CI pipeline. And if you have ideas about that, you want to do a pull request to help us out, that would be great. My name is Stuart. Thank you for your kind attention.